Our project is a little bit different than some of the others, so we're not looking at the actual effects of the Deepwater Horizon spill on the Gulf of Mexico. We're looking at the basic scientific processes that determine how oil gets dispersed in nature in the ocean, and then how that dispersed oil interacts with the base of the marine food web. And then we're also, in the latter parts, we got involved also in looking at the effects of aerosolized oil on human health. So basically we're trying to understand the basic factors of how physical forces in the sea, breaking waves, whether it's a jet of oil coming out from a broken well, how that oil breaks up, what size distribution those particles are, and then how that interacts with living things in the sea. We've looked at, again, one of the goals of this project is to try to provide really good empirical data. In other words, data that's measured in experimental situations under sort of controlled experimental situations that'll help us understand how oil breaks up and what the size distributions of those oil droplets are. Right. That's really important for the modeling efforts. So that's the sort of information you need to model how oil is going to be dispersed in the sea when you have a spill. So we're providing really good empirical data for that. One of the other things that we're really looking at is trying to understand how these small droplets of oil are colonized by hydrocarbon degrading bacteria. So one of the things that we think happened in the Deepwater Horizon spill is that, because there are natural seeps and a lot of petroleum in the Gulf of Mexico, there's a natural resident population of bacteria that can break down crude oil. And so as these small droplets rise, and of course the other big factor is dispersants. If you use dispersants either at the wellhead or on the surface, it's going to break it up into smaller droplets. So we're trying to understand how those oil droplets get colonized by these bacteria. So those bacteria are very small. They actually swim initially, so they actually have to swim and then attach to the surface of an oil droplet as it's rising through the water column. Really the overall goal is to be able to provide the information you need for models, for mathematical models, to try to predict the distribution of oil. So one of the big questions we're trying to address is to try to have better decision-making tools for people that are involved with policy and management of the environment, so that you can populate this with better information. And so compare, for example, if you use dispersants as if you did not use dispersants, how would that change the distribution of the oil? How would that change the interactions with the bacteria, the base of the marine food web, and so on? And how would that affect the production of oily aerosols, which could be potential harm to oil spill workers? So we're trying to understand all these processes, which were not well known before this spill, so that we can add that material to these predictive models, and then hopefully, when the next spill occurs, we'll be able to make better decisions about whether to use one approach or another. Is skimming a better idea? Surface burn, application of dispersants? What are the costs and what are the benefits? One of the things we found, for example, is zooplankton, the small things that the fish you like, when they're larval fish, feed on. They actually ingest these small oil particles, and so they actually are taking up a lot of these PAHs, the toxic substances. So again, we want to be able to provide the information that would be needed to make reasonable decisions about how to treat an oil spill. If we use approach A, how would that impact the environment? So for example, along the northern coast, one of the main things you don't want to have is a big slick of oil coming ashore in really sensitive environments, whether it's seagrasses or a bird rookery or a turtle nesting ground or something like that. So that's the kind of thing you really want to prevent. But let's say if you use dispersants or other approaches, there may be some other potential problems that are created. So you want to be able to look at the costs and benefits and try to understand what, in an oil spill, you want to try to make the least worst outcome. Right. It's not going to be good one way or the other, but you want to cause the least amount of harm. And so we want to be able to provide the information that people will need in order to, you've got to make those decisions on the fly, and it's really, really difficult. But so hopefully by improving these models, they'll be able to run these models very quickly after another oil spill and then be able to make the best decisions that can be made.